Hello again and welcome to today's digital replay. We're still working through Unit 3, but today we're learning about mechanical energy, which is pages 447 to 449 in your textbook. All right, so here's a little thought experiment for you. Would you rather be hit by a 1,000 kilogram truck going 1 meter per second, or a 1 kilogram meatball going 1,000 meters per second? So which one would you rather be hit by? Well, what we do know how to calculate is how hard it is to stop something, which is momentum. So let's start by calculating the momentum of the flying meatball and the truck. So let me get out a piece of paper here. And the momentum of the meatball, we calculate using its mass times its velocity. So its mass is 1 kilogram times its velocity, which is 1,000 meters per second. And its momentum then is 1,000 kilogram meters per second. Okay, so that's how hard it is to stop that meatball. That's its momentum, right? And then the truck... again, we're going to use mass times velocity, and the truck's mass is 1,000 kilograms, and its velocity is 1 meter per second, which gives us 1,000 kilogram meters per second. So they have the same momentum, but definitely one of them would be worse to be hit by than the other. Which one? We still don't have an answer to this question. Which one would we rather be hit by? And it turns out that we have to ask another question. And that question is, how much energy does each of these things have? How much energy does the meatball have versus how much energy does the truck have? Energy is the ability to do work, and it's measured in joules. And what's a joule? Well, a joule is 1 kilogram meter squared per second squared. It's not so important that you have this memorized. Just know that we measure energy in joules, and energy is the ability of something to do work. Or in our case, the ability of the meatball or the truck to do work on your body, right, if you got hit by it. So mechanical energy, which is what we're talking about in this situation and in a lot of situations in this class, can be kinetic energy or it can be potential energy. And kinetic energy is the energy of motion. It's moving things. It's how things move through space, right? So as things are dropped or as things are exploded up into the air or pendulum swinging. These are all objects in motion. So this is kinetic energy here. Kinetic energy is found by this equation, 1/2 mass velocity squared. So 1/2 times the mass of the object times the velocity of that object squared. So again, kinetic energy is the energy of motion, so it depends on the object's mass and velocity. The other kind of energy in mechanical energy is called potential energy. And this is stored energy, and there are many, many, many forms of potential energy. And mostly what we'll be talking about are potential energy as far as like gravitational potential energy. So this is energy that is stored because of the height something is from the surface of the Earth, or elastic potential energy, which is the potential energy that is stored inside of something like a spring or a rubber band. Gravitational potential energy, which is what we're going to concentrate most on in the first part of this part of the unit. Gravitational potential energy is calculated by mass times the acceleration due to gravity times the height of the object. And the acceleration due to gravity is 9.8 meters per second. We'll get to that in a minute. So, in our situation with our truck and our flying meatball, both of these objects are in motion. So we're going to calculate their kinetic energy and see what that tells us about which one we'd rather be hit by. The truck's kinetic energy is going to be calculated by using the kinetic energy formula, which is 1/2 mv squared. So 1/2 times the mass of the truck times the velocity of the truck squared. And what we get is 500 kilogram meters squared per second squared, or 500 joules. So that's the kinetic energy of the truck. The kinetic energy of the meatball is calculated using the same formula. 1/2 times the meatball's mass, which is 1 kilogram, times the meatball's velocity squared. And what we end up with is 500,000 kilogram meters squared per second squared, or 500,000 joules. That's 1,000 times more energy than the truck. So if you ask me, what would you rather be hit by? I would rather be hit by the truck, because the truck is barely going walking speed, and if it hits you with 500 joules of energy, you're more going to just, if you don't fall over, if you have a good sense of balance, you're just going to be able to, absorb that. It's not very much. That truck isn't going very fast, and it doesn't have much energy. So I'd rather be hit by the truck. That's a lot less energy to be hit by. Now, that doesn't help us calculate gravitational potential energy, which we do need to practice calculating for our worksheets and our quizzes and our tests. So I'll give you one more example, which is a diver on a diving platform. So here we have a diver on top of a 10-meter diving platform. So its height is 10 meters. And the diver has a mass of 50 kilograms. In every one of these gravitational potential energy calculations, we will always use that G equals 9.8 meters per second squared. That's the acceleration due to gravity. This number will stay constant. So what is the potential energy of the diver? Well, the gravitational potential energy of the diver is mgh, or the diver's mass, 50 kilos, times the acceleration due to gravity, times the diver's height. So 50 kilos times 9.8 meters per second times 10 meters, which equals 4,900 kilogram meters squared per second squared, or 4,900 joules. That's the diver's gravitational potential energy. Now, why is the gravitational potential energy important? Well, it's important because this can tell us what her kinetic energy will be as she's plummeting toward the water. But we'll get there when we get there. We're not there yet, so we'll get there in the next unit, or in the next digital replay. We're not there yet. So let's sum up. Energy is not momentum. Energy is the ability to do work, and it's measured in joules. Forms of mechanical energy are kinetic and potential. And kinetic is the energy of motion, and potential is stored energy. That's been your digital replay. If you have questions, leave comments below, send me an email, or ask me in class. We'll see you next time.